The combination of the elements to form a compound is governed by certain laws, called laws of chemical combination. The various laws of chemical combination are law of conservation of mass, law of gaseous volumes, Avogadro's law of constant composition, multiple proportions, and reciprocal proportion. Law of multiple proportions. When two elements combine to form two or more chemical compounds, the masses of the element which combines with a fixed mass of the other bear a simple ratio to one another. Let's take an example. Sulfur and oxygen form sulfur dioxide as well as sulfur trioxide. Every 32 gram of sulfur combines with 32 gram of oxygen in sulfur dioxide and 48 gram of oxygen in sulfur trioxide. The ratio of oxygen in both the compounds will be 32:48, which is 2:3, a simple whole number ratio. Hence, it is following the law of constant composition. Law of reciprocal proportion. Let's understand it with a diagram. We have three elements A, B and C on the vertex of the triangle. On the edge of the triangle, we have compound made up of these elements. On left hand side, we have compound formed of A and C, and on right hand side, compound of B and C. Let's take a fixed mass of C in both the compounds. Now the ratio of the masses of A and B, which combine separately with the fixed mass of the third element C, is calculated. This is the step 1. At the bottom, we have compound which is formed by direct combination of the elements A and B. Now the ratio of the masses in which A and B combine directly with each other is calculated. This is the step 2. You can observe that the ratio we get from the step 1 and 2 is same or some simple multiple. So according to the law of reciprocal proportion, the ratio of the masses of two elements A and B, which combine separately with fixed mass of the third element C, is either the same or some simple multiple ratio of the masses in which A and B combine directly with each other. Carbon and oxygen combine separately with third element hydrogen to form CH4, methane, and H2O, water. The carbon and oxygen combines directly with each other to form carbon dioxide. In methane, 4 parts of hydrogen combines with 12 parts of carbon. In water, 2 parts of hydrogen combines with 16 parts of oxygen. Thus 4 parts of hydrogen combines with 32 parts of oxygen. The ratio of the masses of the carbon and oxygen is 12:32, that is 3:8. In carbon dioxide, 12 parts of carbon combines with 32 parts of oxygen. The ratio of the carbon to oxygen in carbon dioxide will be 12:32, that is also 3:8. Hence it illustrates the law of reciprocal proportion.
Hello friends, in the last lecture we have did various law of chemical combinations, and now we are going to study what is Gay-Lussac law of combining volumes. So this law is basically for gases. Initially that the laws were for solids also and for gases also, but now we are going to do specifically about the gaseous atoms or molecules that are being involved to give a particular product. So let us see what does this law means. So Gay-Lussac law of combining volume means what? The law states that when gaseous substances, it is specifically talking about gaseous substances, when react together to form gaseous product, so then the volume of the reactants and products will bear a simple whole number ratio with each other, provided that all the volumes are measured at same pressure and temperature. Means this is the ideal condition that we should maintain while doing a particular reaction for the gases, and so as to obey this Gay-Lussac law. So therefore, let us see an example of it and let us elaborate this definition very clearly in our mind so as to understand it. What does this law means? So now, let us see an example. Like, consider an ideal condition. In this case, the ideal condition is that the pressure and the temperature are being kept constant throughout the whole reaction. Okay, in which 2 liter of H2 gas combines with 1 liter of oxygen so as to form 2 liter of water vapor. So the reaction can be written in this way because I'm doing a combustion reaction which has been involved in this thing, in which 2 moles of H2 is being involved with 1 mole of oxygen molecule. It is not an atom, it is oxygen molecule, so as to give 2 moles of H2O molecules. So in this case, suppose as we have mentioned, that is 2 liter of hydrogen is been involved as well as 1 liter of oxygen is been involved, and these two are of gaseous state, And again, the water will produce will also should be of gaseous state. It should not be of liquid. So therefore, this law clearly indicates that this law is only mentioned or only applicable for the gaseous state reactants as well as gaseous state products. So what we have observed is that the ratio that if we take for a combined for of the volumes, then it has been very clearly mentioned that the volumes will be in a ratio of 2 is to 1 is to 2. So we should also maintain a particular importance or a detail that everything that is been involved should be related and should be in a proper sequence. I cannot write it as 2 is to 2 is to 1. It would be different. So if I write 2 is to 2 is to 1, it means that I am involving 2 liter of hydrogen. I am involving 2 liter of oxygen, which is untrue in this case. So therefore this sequence also matters a lot, and hence we have understood that during a combination of gases, the gases combine with each other in a proper ratio, and you won't get it as 1.13 or in a fraction way or in a decimal thing. So the ratio will be very much simple. So this is a very simple law of a combination of a gases, and that is nothing but known as Gay-Lussac law of combining volumes.
Gay-Lussac's law of gaseous volume. Consider the x volume of gas 1 reacts with y volume of gas 2 to form z volume of gas 3. Then according to Gay-Lussac's law of gaseous volume, this x ratio y ratio z will bear a simple whole number ratio provided the condition of temperature and pressure remains same. Now let's see the statement. It says when gas reacts together, they always do so in volume, which bears simple ratio to one another and to the volume of the products, if these are also gases, provided all measurements of volume are done under similar condition of temperature and pressure. Now let's see an example. On reacting 1 volume of nitrogen with 3 volume of hydrogen, we get 2 volume of ammonia. These volumes bears a simple whole number ratio to one another and to the product. That is 1 ratio 3 ratio 2. Hence, this reaction follows law of gaseous volume. Avogadro's law. Equal volume of gases at same temperature and pressure conditions contains equal number of molecules. Let's take two systems, one with one volume of hydrogen and other with one volume of chlorine, under the same condition of temperature and pressure. According to Avogadro's law, both of them will have same number of molecules. If system 1 have n molecules, then system 2 must have n molecules too. Also, the volume is directly proportional to the number of molecules. The increase in the volume implies increase in the number of molecules. In system 1, we have one volume of gas, and in system 2 we have double of it. So system 2 will have twice the number of molecules that system 1 have. Applying it in hydrogen and chlorine reaction, one volume of hydrogen combines with one volume of chlorine to form two volume of hydrochloric acid. Thus, n molecule of hydrogen combines with n molecules of chlorine to form two n molecules of hydrochloric acid. Law of constant composition. A chemical compound is always found to be made up of same elements combined together in same fixed proportion by mass. Let's take an example of carbon dioxide. Carbon dioxide has 12 grams of carbon for every 32 grams of oxygen. So in carbon dioxide, the ratio of the carbon to oxygen is 12 ratio 32. That gives 3 ratio 8. So carbon dioxide is following the law of constant composition, as it is always made up of same elements, carbon and oxygen, and always mixed in a fixed proportion of 3 ratio 8.
Hey guys, this video is about the quantum numbers. Let's start finding the address of the electron by using the quantum numbers. So what are the quantum numbers? These are the constants which fully describes the electron in an atom in terms of energy, shape, orientation and the spin of the electron cloud in the space around the nucleus. Or simply we can say that the quantum numbers are used to locate electron in an atom. Or in other words, quantum numbers are the address of the electrons. There are four quantum numbers that are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Now look at the four quantum numbers. The first quantum number, principal quantum number, that is denoted by small n. It describes the size of the orbital or the energy level of an atom. Second is angular quantum number, that is denoted by small l. It describes the shape of the orbitals. Third, magnetic quantum number, that is denoted by small m. It describes an orbital orientation in the space along the x, y and z axis. Fourth, spin quantum number, that is denoted by small s or small ms. It describes the spin or the direction in which the electrons spin. Either it spin in a clockwise or the anti-clockwise direction.